Okay, students, today we have a look on chapter 2 with the title Factors and Multiples. So, with the subtopic 2.1 Factors, Prime Factors, and Highest Common Factors, which also known as HCF. So, first of all, we have a look on factors of a whole number. What we mean by factors of a whole number, students? Okay, based on the previous given video that factors, okay, let's say I want to get factors of 2. So I always start from 1. 1 multiply anything, any number, we can get 2. Yes, 1 multiply 2, we can get 2. Hence, we can say that 1 and 2 is the factor of 2. Okay? So, 同学们 factor 呢，也就是说，任何两个号码乘起来可以拿到一个整数，那么那两个号码呢，就是这个整数的 factor. Okay, so now we have a look on the first question. Okay, determine whether 12 is a factor of 36. So the keyword from this question is determine. Okay, so my advice is, for this chapter, whenever you have the keyword determine, what you need to do is you perform division. Okay, so firstly we have a check. 36 divided by 12, we get 3. Means 36 can divide by 12. Hence, we can make conclusion that 12 is a factor of 36. How about example B? 9 is 9 a factor of 30? So what should we do? We perform division. 30 divided by 9. So what we have here? We have 3 remain 3. The remain means balance. It means 30 cannot divide completely by 9. Since 30 can't divide completely by 9, and we can make conclusion that 9 is not a factor of 30. 所以同学们，从这个例子里面呢，我们看到了第一种形式的问题，也就是 determine。determine 呢，就是要你确定一个号码是否是另一个整数的 factor。所以有 determine 这个字眼的时候呢，往往我们都会做除法。那么除出来过后呢，有两个可能性。第一个可能性呢，就好像 example A， 你能够完整的除完。那么呢，这一个案例呢，就是这个号码就是那一个整数的 factor， 因为它能够完整的被它除掉。第二个案例呢，就是 example B， 除不完的，有余数出现。那么这个案例呢，就是说这个号码呢不是另一个整数的 factor. Okay, so now we have a look, okay, on self-practice 2.1a from your textbook, page 33. Hopefully you have complete your work, and now do your checking by using your pen. Okay, if you did mistake, use your red pen to do correction as well. Okay, so this question is, determine whether each of the following numbers is a factor of the number in brackets. So the keyword is determine. So as I mentioned just now, whenever you see this keyword, you need to perform division to check whether it's a factor or not. So question A, we use 40 divided by 12. We get balance 4. So we say that 12 is not a factor of 40. Why? Because 40 is not divisible by 12. Because we have the balance, can't divide. How about question B? 50 divided by 5, we get 10. Yes. So we make conclusion that 50 is a factor of 5 because 50 is divisible by 5. Okay. Next, 24 divided by 8. Yes, we get 3. So we make conclusion that 24 is a factor of 8. Why? Because 24 is divisible by 8. Okay, so hopefully your answer also complete with the reason why this is a factor or why it's not a factor. Okay, if you didn't write on, please add on with your red pen. Thank you. Next question D. 90 divided by 6, we get 15. Hence, we make conclusion that 90 is a factor of 6 because 90 is divisible by 6. Okay, so and the same thing happening on question E, F, G. Okay, all of them able to divide by the given number, so we say they are factor. And lastly, we have a look on question H. 98 divided by 18, and we get a remainder here, means balance. So from this question, 98 is not factor of 18 because 98 is not divisible by 18. Okay, so this is how we determine whether a given number is a factor of another whole number. Just perform division. If can divide, yes, factor. If can't divide, no, not a factor. Okay, next we have a look on example 2. Okay, example 2, list all the factor of 18. The keyword here is list. List means you have to write out all. Okay, 要列出来全部. So class, just now when you get the keyword determine, we do division. Now when you found the keyword is list, we always start from 1. Okay, 1 multiply what number, we can get 18. 1 multiply 18. After 1, continue with 2. Can 2 multiply any number to get 18? Yes. 2 multiply 9 to get 18. After 2, we continue with 3. Can 3 multiply any number to get 18? Yes. 3 multiply 6 to get 18. After 3, we continue with 4. Can 4 multiply any number to get 18? Nope, right? So 4 out of our list. After 4, we continue with 5. Can 5 multiply any number to get 18? Not also. So 5 also out of our list. How about 6? Can 6 multiply any number to get 18? Yes, 6 can multiply 3 to get 18. But anyway, 6 already in our list. That means we have done all the factors here. So right now we just need to list out. Okay, we just need to list out. So where is the factor? Factor, we start from here. 1, 2, 3, 6, 9, and lastly 18. So the factors of 18 are all this number. And students, remember, always try to write the factors in ascending order. Means we start from the smallest factor until the biggest factor. Okay, so with this example, we proceed our discussion on self-practice 2.1a, also from your textbook, page 33. Okay, the keyword lists all the factors of the following numbers. So we start with question A, 15. As I told you just now, we always start from 1. 1 multiply 15, we get 15. After 1, continue with 2. But 2 cannot multiply any number to get 15. So we proceed with 3. 3 multiply 5 to get 15. Alright? After 3, we continue with 4. Anyway, 4 can't multiply any number to get 15. So 4 not in our list. After 4, continue with 5. Okay, but anyway, 5 already in the list. So means we had done. So what we need to do is, don't stop here. List out all the factors. Start from the smallest, which is 1, continue 3, continue 5, and the last one, 15. Okay, so this is the solution that you should do to perform how you list out all the factors of a given number. Okay, next we proceed with question B, 32. So same, we list out all the factors, and lastly, we make conclusion here. Okay, so please do checking using a red pen and also do correction if you did mistake. Okay, how about question C? Question C, okay, these are all the factors. Okay, so the factors of 40, we will have 1, 2, 4, 5, 8, 10, 20, and 40. Okay, so always remember you start from 1. Continue with 2, 3, and so on until the number is repeated there. That means we had done all the listing. Okay, Next, question D. Okay, you do all the way to list out. Start from number 1 and then finally you summarize your factor here. Okay, so the factor you have for 48 is 1, 2, 3, 4, 6, 8, 12, 16, 24, and 48. Okay, so for question E and H, I wish that you can do as how I perform here. Okay, and then you can have a look on the reference at the back from your textbook to do checking for your answer. Okay, so question E and H, you do your checking by yourself with the answer from your textbook. Okay, next we continue with prime factor of a whole number. Okay, so prime factor of a whole number. Okay, so this one, what should we do is we need to perform factor as how we did just now. This is the first thing. Second thing is we need to add on one more condition, which is prime. So now we have a look on what we mean by prime number. Prime number is a number which can only divide by 1, divide by itself, but can't divide by others number. OK， 所以呢，通常呢 prime number 呢，老师会称它为自私的号码。为什么老师说它自私？因为它不能够跟其他的号码分享，也就是不能够除其他的号码。所以记得要怎样确定它是不是 prime number？ 只要那个号码能够除别的号码，它就不是 prime number. Okay, so now we have a look on example 3. Circle prime number from the following. Okay, so the first prime number that we found is 2, because 2 cannot divide by other whole number. And the next prime number, 3. Can 4 be a prime number? No, because 4 can divide by 2. Since 4 can divide by other numbers, so 4 is not prime number. Next, 5. 6, no, because 6 can divide by 2. 6 can divide by 3. 7, yes. 8, no also. 8 can divide by 2. 8 can divide by 4. So 8 is not prime number. 9 can divide by 3. So 9 also not a prime number. How about 10? 10 can divide by 2. 10 can divide by 5. So 10 also not a prime number. Next, 11. Is 11 a prime number? Yes. How about 12? 12 can divide by 2. 12 can divide by 3. 12 can divide by 4. 12 can divide by 6. So many others number. So 12 is not prime number. And the next prime number is 13. 14, no. 14 can divide by 2, can divide by 7. 15 also no, as 15 can divide by 3, 15 can divide by 5. 16 also no. 16 can divide by 2, 16 can divide by 4, and 16 also can divide by 8. How about 17? Yes, 17 is prime number. 18? No. 19? Yes. How about 20? 20 also no, right? Since 20 also can divide by others number. So students, this is the way we determine prime number. Okay? So now we combine the knowledge regarding what is prime number. We moving on example 4. Determine whether each of the following number is a prime number. So the keyword here is determine. So as I told you just now, what we need to do when we are asking to determine, we are going to perform division. So we try 84 divided by 2. Yes, can divide. If can divide, that means it's a factor. Anyway, this question asks us to determine prime factor. So even though it's a factor, but we also have to check whether this number is a prime number. So we continue. 2 is a prime number. Yes, also prime. So we can make conclusion that 2 is a prime factor of 84. 所以同学们 example 4呢跟 example 1不一样的地方就是 example 1我们只需要确定它是不是 factor， 所以我们做了除法，除得完是 factor， 除不完不是 factor。那么 example 4呢，除了要确定它是不是 factor， 第二个步骤呢，我们还要看那个号码是不是 prime number， 也就是双重标准。那个号码呢，必须符合这个双重标准呢，才称得上为 prime factor. Okay, now we have a look on example B. Is 3 a prime factor of 84? So firstly, we do division. Yes, can divide means yes, is a factor. But anyway, is 3 a prime number? Yes, 3 also is a prime number. Hence, we can make conclusion that 3 is a prime factor of 84. Okay, next we proceed with example C. Is 5 a prime factor of 84? So now we do division to check whether it's a factor or not. When we do division, we have remainder. Means what? Means 84 cannot divide completely by 5. Even though 5 is a prime number. So we have two conditions. 5 is a prime number, but 5 is not a factor. So we say that 5 is not prime factor of 84. So remember, the number must fulfill both characteristics, then only can be classified as prime factor. 所以同学们记得，那个号码呢必须是符合这个双重标准，它才能够称得上是 prime factor。只要一个不达标，它就不能够称为 prime factor. Okay, next, example 5. List out all the prime factor of 72. So the keyword here is list out all the prime factor. So what we need to do? First step, we do the factor. How to do factor? As I told you just now, start from 1. So 1 multiply 72, we get 72. After 1, we continue with 2. 2 multiply 36, we get 72. After 2, we continue with 3. 3 multiply 24, we get 72, and so on until you get all the factors here. So these are the factors of 72. Okay, but we haven't complete yet. We only had done step 1. Second step, we need to do prime number. So from all the factor of 72, we have to choose prime number. And we found that 2 and 3 are prime numbers. Hence, we can make conclusion that prime factors of 72 are 2 and 3. So remember, this type of question, you need to do 2 steps. First step, list out factor. Second step, from the factor that you list out, get the prime number. Okay, so this is how we list out the prime factor of a whole number. Okay, we skip example 6 first. We continue our discussion with self-practice 2.1b. Okay, 2.1b, question 1. Determine what should you do? You perform division. Okay, so firstly, we divide 30 by 3. Yes, we can divide. And 3 also is a prime number. So we can say that 3 is a prime factor of 30. Okay, next we continue with B. Is 5 a prime factor of 30? So we divide, yes. 5 also a prime number. So 5 is a prime factor of 30. Next, question C. Is 7 a prime factor of 30? So now we do division, but unfortunately we get remainder balance. Means 30 is not divisible by 7, even though 7 is a prime number. So 7 is a prime number, but not factor. So we say 7 is not a prime factor of 30. So remember, both also must fulfill. Next, question 2a. regarding 54. So here is our solution. Is 3 a prime factor of 54? So firstly, what we do? We do division. Yes, can divide. And 3 also is a prime number. So we say 3 is a prime factor of 54. Question B. Is 5 a prime factor of 54? So we do division. We get a balance remainder here. So we say that 54 is not divisible by 5. Anyway, 5 is a prime number. So what we do now? 5 is a prime number but not factor. So conclusion, not prime factor. Okay. Next, question C. Is 9 a prime factor of 54? So we do division. Yes, we can divide. When we can divide means it is a factor. But we have to check regarding prime number. We found that 9 is not prime number. Is not prime number. Not prime number. Hence, we can make conclusion that 9 is not a prime factor of 54. Okay, so this is a solution for question 1, A and B. Alright, next we continue with question 2. Question 2. List all the prime factor of each of the following numbers. The keyword list prime factors. Okay, so we start 36. Okay, we start here. We start listing from 1. 1 multiply 36, continue with 2 and so on. From the multiplication here, we're able to list out all the factors of 36. Okay, so to get the prime factor, we have to find out which factor is prime number. So 2 and 3 are prime numbers. Hence, prime factors of 36 are 2 and 3. Okay, how about question B? 48. Okay, so firstly also same. We try to list out the multiplication, how we can get 48. And then we list out all the factors. Okay, typing error here should be 48. So all the factors of 48 is all this. But we haven't complete. We need to continue with prime factor. So from the factor, we list out only the prime number, which is 2 and 3 only. So the answer is 2 and 3. Okay, so students, for question C and D also, okay, please kindly check your answer with the answer from your textbook. Okay, the reference behind there, you can check there. So question C and D, you do your checking by yourself. Okay, so we have done this one. And now question number 3. Express each of the following numbers in the form of prime factorization. Okay, prime, you know what is the meaning, right? So how about factorization? It's something about the factor. Okay, so now we back to example 6. This is the prime factorization. So for prime factorization, we have two methods. One of the method is repeated division. We do the revision, repeat and repeat again. But make sure the division that you use here, okay, the number that you are using to divide here only involve prime numbers here. Because we say prime factorization. So the number here are only involve prime numbers. Cannot be others number. Okay, so we have a look how we perform the method of repeated division. Okay, so firstly, 60 divided by prime number. So we always start from the smallest prime number, which is 2. After we divide by 2, okay, 60 divided by 2, 6 divided by 2, 3. 0 divided by 2, 0. Continue with 2 also. If 2 cannot, then only we continue with the next prime number, which is 3. So we get 3 divided by 2, 1. Okay, so we get balance 1, 10. So 5, 2, we get 10. Then we continue. But this time, the division, you cannot continue with 2. Because 15 cannot divide by 2. So the next prime number after 2 will be 3. 15 divided by 3, we get 5. We need to divide until we get 1 at last. So 5 cannot divide by 2, cannot divide by 3. So the next prime number will be 5. 5 divided by 5, 1. Yes, finally we get 1. Done. So what you need to do is, with all the prime number on the left hand side, you list out, then this one will be your prime factorization. Okay? By using the repeated division. You just repeat. And the second method will be drawing factor 3. Okay, so this is the tree diagram. You see the tree diagram. Factor. And also because prime factorization means we can only use prime number. So how to do factor 3? That means you break the number, you break it until all become prime numbers. So firstly, 60 I can break to 4 and 15. Anyway, 4 and 15 is not the prime number yet. So I break them again. 4 I break to 2 multiply 2. Yes, these 2 prime number, done. How about the right hand side, 15? I break it to 3 and 5. And 3 also is a prime number, 5 also prime number. So finally, I can list out. This last row will be my answer. Okay, anyway, we can do this factor 3 by using another method. I can break 60 to 2 and 30. That means 2 multiply 30, I can get 60. 2 already is a prime number, so I just bring it down. Anyway, 30, I still can break it. I break it to 3 and 10. So 3 already a prime number, I just bring it down. So what I need to do is I break 10 to 2 and 5. And 2, 5 also prime number. Okay, so finally the last row all become prime number. That means I done my prime factorization. So I just list out here. Okay, so remember, prime factorization only involve prime numbers. Okay, so now we have a look on the self-practice question 3. Express each of the following numbers in the form of prime factorization. Okay, I will try question A, 42. Okay, so we try here 42. 42. So firstly, I do repeated division. Okay, I do repeated division, yeah. I show you repeated division, how we do it. So first method, I perform the prime factorization by doing repeated division. So 42, I will start divide it by the first prime number, which is 2. So 4 divided by 2, I get 2. 2 divided by 2, I get 1. Continue, but this time 21 cannot divide by 2. So I continue with the next prime number, which is 3. 21 divided by 3, I get 7. Continue again. 7 can divide by the next prime number, which is 7. So finally, I get 1. Finally, I get 1. So I can do conclusion that 42 is where I get my answer. Yes, I will get the answer from left hand side. 2 multiply 3 multiply 7. So this is how I perform prime factorization using repeated division. Okay, and now I show you by using factor 3. Okay, so by using factor 3, so I will have 42. I try to break it. 42 can be 2 multiply 21. So 2 already a prime number, I just bring it down. So at 21, I can break it to 3 and 7. So check. 2 is a prime number, 3 is a prime number, 7 also prime number. So at last, I can say that 42 is 2 multiply 3 multiply 7. Okay, so remember students, for prime factorization, your answer only involve prime numbers. Cannot be others number like 4, 6, 8 and so on. Cannot. Only prime numbers. Okay. So another question will be 96. 120, 135. I wish you try on yourself, and then you can have a check with the reference behind your textbook. Okay, so any problem we will discuss on the next discussion. Okay,